Welcome, my physical science class. Mr. Hescox, trying to throw some chemistry into our life. Some of this stuff I have here for you is to talk about some of the properties of chemistry. We talk about characteristics of chemistry or chemical reactions, that you have to have something new created. Not only do you have new things created, you have temperature changes, you have gases created, and in some cases you can even get precipitates created. So the first reaction I was going to show you, this is plain old rubbing alcohol. So I poured a little bit of this rubbing alcohol into here, and rubbing alcohol burns at a much lower temperature than what you would normally expect a lot of things to do. So when we start it, it should burn at that nice clean color, and notice how my rag's not burning. So that is the release of light, release of energy. You've got an energy change. You've clearly got a temperature change. So there's a combustion reaction. Notice that little piece of a rag I used is not burnt. The alcohol burns at a much lower temperature than the rag, but it does burn. So that was my synthesis reaction right here. You have isopropyl alcohol. When you have anything burning, you react it to oxygen and you get carbon dioxide and water. So now we talk about formation of a gas or bubbles being formed. So here's a real good one for formation of a gas. So I'm going to take just some plain old water from one of these little bottles, and I'm going to react it to, we're going to use these Alka-Seltzer tabs, which are used pretty common in a lot of 8th grade experiments. Now when you put the Alka-Seltzer tab, it's got citric acid and it has sodium bicarbonate in it. And when you put it into the water, bubbles form. And those bubbles are actually giving off carbon dioxide gas. As it reacts. So there's your formation of a bubble. So I have one more experiment I want to show you in this video. So there's lots of different chemical reactions we can do with vinegar. This is regular old vinegar from the store. I'm going to put a little vinegar in this container right here. You can clearly smell the vinegar here. And now what's interesting is, yes, you can see the bubbles in that. But I'm going to show you that I can prove to you that the gas is formed, and the gas is clear. So this is baking soda. You probably have this in your kitchen. When I react it, you get lots and lots of bubbles. The bubbles being given off here are also carbon dioxide gas. Now, what I'm going to do is just put my hand over that, because that carbon dioxide gas is heavier than air. So one of the neat things about carbon dioxide gas, it stops combustion. So in stopping combustion, you can actually pour carbon dioxide gas, if I collect enough of it in there. And as I pour it, without pouring the liquid out, it should put out the fire. That is production of a gas that you couldn't see that put out my candle. To combine the two reactions, Bryson's lighting the alcohol right now. As you can see it burning. Now the carbon dioxide gas is still going in there, and if he lowers that down into the vat where the carbon dioxide gas is, it puts the fire out.
Show it again.
Yep. There's still alcohol in the rag. So we have alcohol in the rag. The carbon dioxide gas has not left the bowl, and it puts the alcohol flame out. Those are chemical reactions. In each case, you have a new substance made. You have an energy change. And, well, not this. This had a light released. These ones, this one would become colder. This one actually heats up a little bit. But the carbon dioxide gas is clearly produced. And until next time, guys, I'll catch you later. I'm Mr. Hescox. See ya.